Hello everyone, my name is Henry Stewart. Sorry for the raspy voice, I'm under the weather. This is Physics Lab 1 for Physics 2211. This week's lab is all about constant velocity. Let's get right into it. The purpose of this lab is to demonstrate and verify Newton's second law of motion. So we're comparing data from the lab and from a computer simulation. Newton's second law defines a force to be equal to change in momentum per change in time, which can also be written as F net equals dp over dt, which in layman's terms is the net force is equal to change in momentum over change in time, which can be taken a step further, where the final momentum is equal to the initial momentum plus the net force times the change in time. And if you divide that whole equation by the mass, you get a velocity update formula, where you can see below. As a preview for my experiment, I tracked the motion of a rolling marker, which proved to support Newton's second law and the equations on the previous 2 pages. So for my procedure, I recorded the motion of marker rolling along an even whiteboard with constant velocity. Then I used the tracker app to track the position of the marker, and then I used GlowScript to create a simulation of the motion of the marker. And then I compared the data from tracker and from GlowScript on a single graph, which you can see later. So I began to track the marker once it came off the ramp and on to the level whiteboard, so that there was no external force on the marker. So in other words, the surroundings weren't affecting the system anymore, the system being the marker. At that point, when it came in contact with the whiteboard, the initial position was 0.0023 meters, and the initial velocity was 0.651 meters per second. Here is the video. Tracker does a pretty good job of tracking the marker. Pretty cool. And then you can see the graph that tracker gave me. Also kind of cool. You can see how it has a curve. We'll talk about that later. Here's my code from GlowScript. Lines 35 and 36 are where I set the initial position and velocity, and then 39 and 40 are where I set the initial time and the change in time. 58 and 60 are where I update the position and velocity. Velocity never changes since the F net is 0. And then the mass has no effect on the change in position, so it can just be whatever, so I left it as 1. Here's the graph that GlowScript gave me, and then here's the graph that I made. So, the red line is the graph from GlowScript, and then the blue line is the one from Tracker. So, as you can see, the one from Tracker tails off a little bit, and that's because the net force is likely non-zero. There's likely air resistance and friction, which caused it to slow down during the experiment. So, questions. What if the positive and negative x-axes were interchanged? Well, then the graph would have a negative slope. So the line would be high in the beginning and low in the bottom, because as time goes on, the marker would be getting closer to a big negative number. Another question. Would it be possible to find the forces that give a net zero force on the system? That assumes that there was a net zero force on the system, which our data says there's a non-zero net force on the system. Even though we are trying to get a net zero force, in the real world, often there are little net zero forces. even if there was a net zero force, we would not be able to find the forces that did so. The air resistance is so small, and the friction is also so small, that it would be near impossible to find.